guys, I wanted to go over um, 1.2 with you guys, which is on special applications of ratio proportions. So even if you guys do not have your book yet, you guys should still be able to follow along with the videos and still be able to complete the work for this week. So I showed you guys a video on 1.1. 1.2 is still a continuation of ratio and proportions. There's just some special applications that I go over. So if you guys are in auto mechanics, you will see, you will probably have some experience with drafting. I didn't really know anything about this until I started teaching this class. If you look in your book, you have an example of a car. And this is on page 20. And if you notice in the book, it gives you a proportion of your actual length versus the drawing length, and then the actual width versus the drawing width. So this is the proportion that your book gives on this. Make this a little bit bigger. All right, so let's look at this. So you have your 16 feet 6 inches versus your 4 1/8 inch equals 6 feet over 1 1/2 inch. And then all the units need to be in the same so that everything should be put into inches. So whenever you're looking at a proportion, you want to have the same units because you want to be able to compare apples to apples or oranges to oranges, right? If you have all of these into inches, then you need to have this one right here also into an inch. So just remember, we know that 12 inches equals 1 foot. So if I have 6 feet, we're going to get into conversions a little bit later. I want to convert this to inches, right? So how many inches is in a foot? We know 12 inches in a foot, okay? So if I want to get rid of feet and I want to convert it to inches, we're going to be, this is called a unit conversion. We're going to be doing this a little bit later. We know 1 foot is 12 inches, so that means you have to take 6 times 12. And that's going to give you 72 inches, okay? But we also need to convert this one right here, okay? So it's the same thing, 16 feet. I want to convert this to inches. So we know 1 foot is 12 inches, and that's going to give you 192 inches. And then we can add this 6 inches to it. So we'll say plus 6 inches. Okay, and that's going to give you a total of 198 inches. And I kind of wrote this out in words here. But so now our new problem is going to be 198 inches on top versus 4 1/8 inch. That's the drawing length. This is the actual length. Equals 72 inches, which is the actual width, and 1 1/2 inches. Okay, now when we have fractions, one of our reviews was looking at fractions. What you can do is we can change this into an improper fraction. Okay, I don't know if you guys remember how to do this, or you could also just change it to a decimal. If you do 1 out of 8 on the calculator, that's going to give you 0.125. So 1 out of 8 is equal to 0.125. You guys can use a calculator in this class, so it's easy to convert. So this would be 4.125. We could also change this into an improper fraction, and I don't know if you guys remembered how to do this, but you take the bottom number of the fraction, you multiply it by the whole number, and then you add this number. So that would be 32 plus 1 equals 33 out of 8. And if you check that in your calculator, 33 out of 8 gives you this same number here, okay? So when you divide those, okay, when you take 198 inches over 4.125 inches, it's going to give you this 48 inches, okay? And we're checking to see the question here on this was asking for, is it equal to the square width, the scale, are they equal, okay? So then the same thing here, 1 1/2 inches is the same thing as 1.5. So you're saying 72 inches out of 1.5 inches, okay? And when you do that, you get 48 inches. So this is the same as this. So the scale is the same. The scale factor for this would be 48 out of 1. Okay? And they're the same. They're proportional. All right, example 2 is another example of scale factor. And this time you're actually looking for, you're solving for this one. You want to figure out, okay, what is x here? So again, we have feet here and feet here, and we have inches down here. So we need to convert everything again so that it has all the same unit. So again, it's easier to convert feet. So let's do feet. How many feet are in 1 inch? There's 1 foot in 12 inches. Okay, again, we want to get rid of the feet. So you do 18 times 12, and you can easily put that in the calculator, and that's going to give you 216 inches. Okay, and the same thing for this one, 12 feet. We want to convert this to inches. Now, a lot of you guys can just do this in your head, I would hope, and you end up with 144 inches. So we replace our 18 feet with 216 inches, replace 12 feet with 144 inches. Now, how to solve a proportion? We do it similar to what you can cross multiply here. All right, so you end up with 216 times x equals 144 times 4.5. I'm hoping this is a review to you guys for solving proportions. Cross multiply here. And we put this in the calculator, 144 times 4.5. It's going to give you 648. All this is in inches. Okay, now how do I figure out what x is? How do I get x by itself? This is a little bit of algebra, so if it's been a little while for you guys, this is hopefully we'll review over it for you. These two are multiplying, so to get rid of this number from x, because we want to get x by itself, we do the inverse of multiply, which means divide. So we get rid of it on this side by dividing. And when you divide 648 divided by 216, you will end up with 3. And so what happens is you end up with 18 over 4.5. Is that equal to 12 over 3? Okay, well, you can check this. 18 divided by 4.5 is going to give you 4. So this ends up being 4 inches. And we know 12 divided by 3 is going to give you 4. So those are equal. So we know that we did our job here. You can always check your answer. Okay. All right, if you go in your book on page 22, there are some other examples of similar figures, but you can also, I have attached a video for you guys to watch here on similar figures that goes more in depth on this. So make sure you take a look at those. And if you have your book, you can take a look at it on the in the book. But what it does is it just compares similar figures. So meaning if you have this triangle, okay, let's say this is A, B, and C. And then I have another one that looks just like it, but it's just a little bit smaller. And this is D, E, and F. These are what you call are similar figures, okay? And so what that means is we're going to need to compare proportions. We can compare that this side is similar to this side, right? We can compare that this side is going to be similar to this side, and we know that this side is similar to this side, right? So when you look at these, we can compare, you know, A compares to D, and AC, because let me say AB compares to DE. And we can say AC compares to DF, and we can say BC compares to EF. Okay, so notice how all the top are this triangle and all the bottom are this triangle. Okay, and so this is what that video goes over for you guys. Any questions on any of this stuff, you guys please email me. Let's go to the next slide. Let's see. So I'm going to put one up here for you guys that you guys can try on your own. And if you don't have your book, I'm doing the one in your book on page 23. And I'm doing the Your Turn on part A. You don't have your book, though. I'm going to write this down for you guys. This is 10 inches. This one is 12 inches. And feet. These are feet. Sorry. Inches is 2 dashes. And then we don't know A, but I do know that this is 4 inches. Okay. All right, so again, if you don't have your book, you can take a look at this in your book and try this example on your own. But what we see here is, again, I have feet, this is feet, and this is feet, and this is inches. So what I need to do is convert everything to the same. So again, I have 10 feet, and I want to convert this to inches because I already have inches over here. So 1 foot, 12 inches. This is going to give you 120 inches. And then 12 feet, 12 inches is going to give you 144 inches. Okay, so now let's compare. All right, so I'm going to redraw this. Now I have a length here of 120 inches and a length here of 144 inches. So let's compare what's similar. I know that 120 inches compares to what? It compares to the 4 inches over here. And I know that 144 inches compares to the A over here. Okay, so you want to always make sure you do the same comparison. All right, if you start out with this triangle first on the top, then you start out with the triangle, the same triangle on the top over here. And then we cross multiply here. So 144 times 4 is equal to 120 times A. 144 times 4 gives you 576 equals 120 times A. Again, how do I get A by itself? We end up dividing by 120. And so you end up with A is a length of 4.8 inches. Okay. If you have your book, you can try the other example too, but if you don't, that's okay. All right. The next thing in your book talks about direct proportion. For direct proportion, you can have it going to, when you're looking at something, as you increase your X value, your Y value also increases. Or you could have something that as you are going, let's see, as you're going this way, it decreases. So this, as your X is decreasing, your Y is also decreasing. So direct variation formula is y equals kx. Now, if you were to solve, that means k times x. If you were to solve for k, which is known as your constant variation, you would have to end up dividing this by x, okay? So that comes from this formula right here, okay? In electrical trades, the longer the wire, the greater the resistance. So this is an example of direct proportion. The longer your wire is, the greater your resistance, okay? So it's just giving you a direct proportion here. If you have 88 wedges over 2 hours, how many wedges would be over 3.5 hours, okay? We're still doing the same kind of proportion here. Notice wedges over hours, okay? And then you would still simply cross multiply. 88 times 3.5 is equal to 2 times x. I wrote this out right here. And then you end up dividing this by 2, and you'll end up with 154 wedges. It's just another example of how we would use proportions in real life problems, okay? And this is on, let's see, this is on, in your book, page 20, let's see there. I did a different example. Direct proportion is under page 24, okay? You also have inverse proportions. That means as you increase your x, it decreases. So as you're increasing x, your y is decreasing. Or you could also do vice versa. As you're decreasing your x, your y is increasing, which looks like this. Okay. So it's inversely proportional, so that means that y is equal to k over x. So in order to solve for k, you would end up multiplying by x here. Okay, so you would end up k equals x times y, so you would end up multiplying. There's an example of this on page 27 in your book, and for inverse, and an example of this is gears and pulleys. So the relationship between a gear or pulley and then the speed with which it travels. So time for a trip is inversely proportional to the speed of travel. Relationship between the size of a gear pulley and the speed in which it rotates. So for example, speed of gear A over speed of gear B is equal to the teeth of gear B and then the teeth of gear A. So notice how these switch, okay, for inverses. So if you have a problem and you have the speed of gear A is 40, and then you know the teeth of A is 16, that goes on the bottom. We're trying to find the the speed of gear B, and you know the teeth of B is 8. So still we set up very similar, except this time you switch the two, and then we cross multiply, and you would end up 40 times 16 is equal to 8 times X. Still solve it similarly, and you end up with 80. So this is the speed of gear B. Okay. And then that's it. So your book goes over more of this, but again, all of this is just using proportions. The only difference with this one is you're setting up your, the inverse relationship means you're switching these, okay? So if something talks about something being an inverse relationship, you guys are going to need to know that you have to switch these. And that is pretty much it for this section. If you guys have any questions, please email me.